Hey, welcome back to Workplace 30. We're continuing on with 6.1 single transformations, starting with example 3. What are the coordinates for the labeled vertices after they have been rotated 180 degrees around the origin? So I'm going to start by writing 3 of my original vertices. I'd like you to do the rest. So I write vertex A is -1 and 4 because it's -1 here on the x and +4 on the y-axis. So that gives me A of -1 and 4. Now when I rotate it, and I've already drawn the 180 degree rotation, we're rotating it around the origin. So as it's rotated, your A prime will now be on this side, your B prime and C prime and D prime. So the new label for A prime is now +1 and -4. So as written here. What do you notice about these two vertices? Okay, you'll notice that they're the opposite signs. So for example, A has a -1, but A prime has a +1. A has a +4, A prime has a -4. This trend also continues for B and C. See if it continues for all of the rest of the vertices. So part B then is we're going to draw 90 degrees and 270 because we already drew the 180. So if I rotate this 90, the new bottom part of my snowflake would be there, and again it goes up 4 either side and looks something like this. Same with on the other side. There we go. So your snowflake should look something like that. Then we're going to go to discuss the ideas on page 233, impeller maintenance. Wesley is doing maintenance on the impeller blades from an industrial fan used in a large office building. List the ordered pairs of each of the 4 vertices on the impeller blade. So each of the 4 vertices means each one of these has 4 vertices. So go ahead and tell me the vertices for each of them. If there's more than one person in your class, split them up among your class members and then compare your results. So I did G, H, and D here for you. Now note that this area here is called quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Those are important to note as we continue in this chapter. What do you notice about impeller blades that are rotated 180 degrees from each other? So ones that are rotated 180 degrees should have opposite signs. So for example, if one is a -1 and a -1, the one that's 180 degrees from that should be 1 and +1. So here we have H and we have D. H and D would be would be rotated 180 degrees from each other. Do their vertices match up? So here we have these two do, so that's good. These two do, again, they're just opposite signs. These two do, and this last one does not. So question 2, which blade is out of alignment and how do you know? You know that it's either H or D that's out of alignment because one of these coordinates does not match up. So let's look at H and let's look at D. D has this point right here where this line is actually crooked. It should be a straight line like it is in all the rest. So that tells you that D is out of alignment. So question 3A, which blade is 180 degrees clockwise rotation of blade A? That would be E. And if you look at your vertices that you came up with, they should all be identical but opposite signs. How about for part B, 270 degrees counterclockwise of blade H? So counterclockwise from H is going this way. So which one would be 270 counterclockwise? All right, so then for part B, the one that is 270 is, of blade H is B. Now, if you look at your vertices that you came up with for B and for H. You'll see this. You'll see that all of these numbers are just flipped. They are 0, for B it's 1 and 0, for H it's 0 and 1. You'll also notice that all of the x coordinates here for H are negative. That's because you need to look at what quadrant it's in. In quadrant 2, which is where H is located, x is negative. But B is located in quadrant 1, where x is positive. So that's why in B you've got all positives, H you have all negatives. Question C, which blade is 90 degrees counterclockwise from H? So H is here, 90 degrees counterclockwise would be F. So now if you compare your coordinates of F and B, you know that B and F are 180 degrees rotated, so their signs should all be opposites. You also know that H and F, so they're 90 degrees rotated. The numbers are again flipped, and if you look at F, because F is in quadrant 3, all of your X's are going to be negative, and all of your Y's are going to be negative, because quadrant 3 has all negative X's and all negative Y's. Here we have Anita, who is making proportional candles. The first one is 9 centimeters wide, 8 centimeters tall, and she wants to create the smallest candle, which is a dilation of the first one. Dilation means proportional, and that's a scale factor of 2/3. So we can figure this out by using proportions. So if we have 9 centimeters, so if you have your width, your new width is what you're looking for, your old width is 9, you know that it is being changed by a proportion of 2/3. Note that since you're making a smaller candle, your width would be on top with the smaller number because 9 is the larger of the two numbers, so it should go in the bottom with 3. Cross multiply, and you'll find that W equals 6. We can then do the same thing for the height. So we have height over 18 equals 2/3. Again, the height is going to be smaller than the mid-sized candle because we're talking about the smallest candle. So H here is 12. So your new width is 6, your height is 12. Part B, she's got a special set of candles. The first is 12 wide, 8 deep, and 10 tall. The second is 15 wide, 10 deep, and 12 tall. Are these a dilation of each other? So what we need to figure out is, let's first make a proportion of the widths. So we have 12 over 15 because this is going to be the first, and this one is going to be the second candle. So 12 over 15. If these were perfect dilations, they would have the exact same proportion. So 12 over 15 would be the same as 8 over 10, which would be the same as 10 over 12. Where this here is how tall they are, this is how deep they are, and this is how wide they are. So if these are equal, then it is a perfect dilation. So 12 over 15, so is 0.8, which 8 over 10 is also 0.8, but 10 over 12 is 0.83. So that does not equal. So that means that, therefore, no, it is not proportional. So that's how you would use a scale factor. Discuss the ideas. Here we have an interior designer who likes to make things have some symmetry. In 3D, the reflection line is called the plane of symmetry. Where is the plane of symmetry in this living room? So this is a little bit tricky because it's a 3D image. So the plane of symmetry would actually come right down between the windows, split those two red pillows, and when it hits the floor, it would go through there. So that makes sense. It's a full 3D plane. That would be the symmetry. So B, list 4 pairs of objects that are reflected over the plane of symmetry. Here are some things that we found were symmetrical and then were not. Part 2 of this discuss the ideas, we have an air traffic controller. To manage airplane takeoff, she uses this wind stalk, which will tell which direction the wind is going. It can be indicated by degrees, just like true bearings. So remember true bearing, it always starts at north and then we'll go in a clockwise direction to tell how many degrees. So something like this might be 145 degrees. True bearing. So here, part A, we have a wind stock at the Regina Airport showed a northwesterly wind of 315 degrees, then shifted to a north wind of 0 degrees. How many degrees did the wind stock rotate? So this north would be 0 degrees, and it was here at 315 degrees. So how far then did it have to go to get back to north at 0? 45 degrees, good. Try B on your own. It changed from southeasterly, so exactly southeast, to exactly west. How many did it rotate? And you should have got 135 degrees. Last one. We have the Port of Vancouver handles more than 100,000 shipping containers every month. A crane moves the storage box. It moves it in 3 separate steps. So in the first step, it moves 3 meters left, 2 meters forward, and 5 meters up. The second step moves at 1 meter right, 1 meter forwards, and 4 meters down. And last step is 4 meters left, 3 meters backwards, and 1 meter up. So what I did to do this is I'm organizing my data in up, down, where up would be positive, down would be negative, in left and right, where left would be negative, right would be positive, and forwards back, where forwards would be positive, backwards would be negative. So let's start with just the very first step. It moved 3 meters to the left, so it moved -3. It moved 2 meters forward, so it moved +2. It also moved 5 meters up, which was +5. Then the second step, it moves 1 meter right, so +1. It moves 4 meters down, so -4. And it moves 1 meter forward, so +1. Then your last step, it moves 4 meters left, 3 meters backwards, and 1 meter up. So where did this end up? So when we combine these, you find that in all, you moved 2 up, 6 left, and 0 forward and backwards. Last but not least, you have a homework assignment, page 226, number 5, 6, 7, 8, and 9.